to SMIT just 6 months back. So I don't know what made him to recommend my name to management studies. I do not know. Because naturally I'm a very talkative guy. I spoke at length during my sessions. I took electric vehicles for the mechanical engineering students. Probably that would have impressed him. He suggested my name to the management department. I belong to manufacturing engineering. Thanks for the nice introduction. I do not know the person. Okay, anyway, the discussion is going on. Fine. Thanks for the nice introduction. I'm from manufacturing engineering. I've got some 32 years of experience, both in academia and in industry. So in industry, I worked as production engineer, supervising engineer. I designed a lot of jigs and fixtures that help in manufacturing, in machining. And I did my research in advanced materials, nano materials, and how those materials can be machined using advanced machining technology. That was my area of research. And I worked in institutions for more than 26 years. After that, the L&D people wanted my experience to be utilized to carry their courses across the nation. So I'm part of L&D for the past 4.5 years. So my association with L&D is not even a decade. It's just 5 years only. But I had the opportunity to interact with the experts from our industry. They are doing a lot of things. L&D is not just confined itself only to construction, because L&D is known for its construction. Everybody knows. If you could see a bridge, a road, a dam, immediately L&D comes to their mind. But L&D is not that. L&D is into a lot of other things. I have a video to support that. Let me play that video as well. But when it comes to management, because I've gone before the start of this session, I went there and I meet most of them in person. I shook hands with them because I want to check the pitch. If at all you want to play cricket, it is necessary for you to read the pitch, whether it be batting or bowling, right? So based on the pitch you can play, right? Fine. Then most of you are from management. I see finance is there, right? Cloud computing is there. I don't find any mechanical or manufacturing, and madam told me that Dr. Amit has come. He's coming, okay. He's the only person who has got a mechanical engineering background. Anyway, let me try to bring everything there and make the session interesting, right? Because if you keep on talking on mechanical engineering, manufacturing engineering, definitely that may not interest you, right? But let me try to make it interesting, right? Fine, thank you. It's about the overview of my presentation today. L&T, what is L&T conglomerate is all about. Then production management, elements of digitalization. Of course, come on, the area is shifting. Elements of digitalization. Of course, you require digitalization, right? Even most of your finance, banking, insurance sector, you require digital elements. Okay, you require digital elements, right? We cannot escape from that. Then AI in production management and few case studies. And most of them are related to engineering only. But let us see how far it will be useful to you. Is it possible for me to play the video here? Can anybody please help me? It's a video attached to it.
Yes, sir, want to play a video here.
Just play it quickly.
Just play, you press it and go, no? Okay. I'll go there. Yeah, it's sorry.
closer than we think. Using digital technologies, we're implementing futuristic solutions to make quantum improvements across all our businesses, resulting in smart engineering, smart manufacturing, smart project management, smart infrastructure. Our proven global expertise in infotech, as well as technology services, enables us to solve complex business problems at the convergence of the physical and digital worlds, both internally and for major clients across the globe, including a large number of Fortune 500 companies. Disruptive technologies, like the Internet of Things, are changing the way we live and work. We are leveraging our rich engineering heritage with these new technologies to offer businesses worldwide services that enhance efficiency and productivity. By exploiting analytics for innovation, we are transforming the way these industries operate. Cities are the beating heart of the world's economy. Their speed and scale of expansion presents a choice: megacity turmoil or an inviting urban environment. A smart city. A smart city involves the application of information-based systems for better governance and services. With expertise in both infrastructure and new-age technologies, L&T has the edge in implementing India's mission to make 100 cities resident-friendly and sustainable. Every day we help light up hundreds of villages and power businesses and industry. We provide a complete range of solutions for power plants, from concept to commissioning. Our heavy engineering facilities are among the largest and best equipped in the world. They fabricate complex large-size equipment for core industries and provide critical equipment for India's nuclear power plants. We are the only company with the capacity to build an entire nuclear power plant on its own. Nuclear fusion has the potential to replace every other source of energy. Larsen & Toubro is collaborating on a global project to build the world's first thermonuclear reactor in southern France, a potential step towards an abundance of energy that could power the planet for millions of years. Till such time alternative energy sources reach full maturity, hydrocarbons remain the principal source of the world's energy supply. Our presence spans the entire hydrocarbon value chain, from exploration to refining to erecting complete plants. Through products derived from hydrocarbons, we touch your life every day. In a myriad other ways, we are a recurring presence in your life, day after day. Moving you through airports built by us, over bridges, roads and intersections that we have constructed, through state-of-the-art metros that we have built. And as you arrive at your destination, an array of properties await you, built by us to the highest standards. Whether it is the tallest, longest, largest, we at L&T have built it. We apply technology to man's most precious resource, water. Our ability to build a world-class water infrastructure covers all aspects of treatment and conservation, including desalination. We have played our part in India's mission to the moon and its thrust to orbit Mars. For decades, we have made critical aerospace components for the country's space program. Through our technology leadership, we now have the capability to build complete launch systems to place satellites into orbit, opening up limitless possibilities for the future. Technology is pushing from every direction. The future doesn't belong to the faint-hearted, it belongs to the resolute. It belongs to those who strive, who seek, and do not yield. The future belongs to the brave.
That is L&D for you. One.
I thought it was just confined to the
No,
construction.
it is not. That is why I chose this video. It was lying somewhere in the archives. I searched it because I can keep on talking about the works taken by L&D, the projects taken by L&D, but that may not reach the people. So if I show that in the form of a video, definitely that attracts, right? It's really impressive. And I take pride in the fact I'm part of such a big legacy, right? And the new venture is L&D EduTech, and we are part of it. The reason that they've started L&D EduTech is that to bring in the expertise. We have a lot of people working in a lot of projects, right from construction to heavy manufacturing, to space research, to material science development, even in conservation, like water preserving, desalination, bringing in the fusion energy, a very big project that is going on in France, right? It is really, breathtaking to share this particular information with you, that the core temperature of that thing is somewhere around 150 million degrees centigrade. That is 10 times equivalent to the core temperature of the sun. If that is coming on the earth, if something untoward happens, what will happen? The ocean will evaporate in no time. Everything will be charred. But still people are putting a lot of effort to do that research. For that, that brings in the kind of freedom from that energy starvation or whatever it is, the crisis that we have in the form of an energy. So they are providing solutions for everything. So what is the role of management here? It's an important question because it's a management gathering. Of course, we require management people to make it operational. We can give technical support. We have expertise in engineering and technology, but the implementation lies in the hands of management. Then where comes generative AI here? That's the question. The purpose of this FDP is to gain some inputs or some insights on generative AI. What way we can contribute? AI contributes in what are the ways? Of course, we know that. You collect the data, you analyze those data. Those data will give you a lot of information, and based on that information, you take your decisions. That is your artificial intelligence, right? What is generative AI? In general, I'm talking to you. So I'm not a very big expert in generative AI. My focus is only on mechanical engineering and manufacturing engineering. If I make a mistake here and there, please correct me. The faculty development program, in my perception, is not that someone comes here and teaches you certain new things. For me, it is a learning, collective learning is what I would like to say. If it's a quite interactive session, I'll be really happy. Right? If someone comes forward to present their views, I'll appreciate that. I'll certainly appreciate that. Even if you are in to correct me, of course, I'm here to learn, not to teach. Right, sir? Fine. That's generative AI, we'll see, and all those stuff. And the widespread of L&D that I have shown. In addition to that, we are, just because I'm a guy from manufacturing, definitely I'll touch generative AI We'll discuss a lot on generative AI. Don't get scared. Okay, this guy is showing too many, machineries and all. Please don't be of that in that opinion. This is the world's largest tubular reactor. L&T is manufactured. See the weight of this reactor: 1,500 metric tons. That is one piece, sir. One big piece is 1,500 metric tons. The diameter is 10 meters. Can you imagine the diameter? What would be the height of this room? How many meters it would be? Probably 2 meters, 2.5 to 3 meters. 3 meters, right? 9 foot, right? 10 meters means what? Very big structure. Length, height. They are manufacturing it. The world's largest. That's the reason for it. I'm telling you, I'll connect that with your generative AI. Definitely, I'll connect that with generative AI. Then another thing, it's a special steel and heavy forging. It's a component, one single component. This is the machinery. The height of the machinery is somewhere like a 3-story building. The building is in one shot, we can create this particular part. It's a red hot component. You could compare the size of this component with the people standing here and discussing. See to the size. And this is 9,000 metric tons. This is mechanical engineering, guys. Definitely, I have not discussed a lot of nuances related to this thing. But the management area, we'll have to cut short certain things. Then it's a pressure critical piping, a huge pipe that has to be bent, right? The machinery will be like this entire building. The machinery itself will cover the entire ground floor. The space will be of that, size. Only then you can bend a tube of this many meter diameter into a curved shape. All these things are used in nuclear power plants, reactors, refineries. We use these tubings. I'll come to this point. Come on, don't get think that is taken somewhere else. Right, world's hydrocarbon reactor, 19,000 metric tons. The value of one particular piece is 3,448 crores. You could manufacture one particular reactor that gets a revenue of course, expenditure will be there, right? Manufacturing cost and everything will be there, right? Right. These are all the construction delights already shared it in the form of a video. Now I'm coming to. I'll start with engineering, and I'll give a question. How to relate that with your artificial intelligence or generative AI and all those stuff. Will relate later on. See here, whatever the things that you have seen earlier, a reactor, for example. We call this as a reactor shell. One cylinder is a reactor shell. Another cylinder is a reactor shell. We join these two shells together with the help of an engineering operation called welding. We call that as submerged arc welding. For any process to go on, if the process has to yield you a good result, a quality component, certain parameters must be taken care of. That is everybody's understanding, that you need not have to be an engineer for that. Right? In welding, we have got certain parameters. Right? What are those parameters? That is, we are doing an electrical arc welding. If it's an electrical arc welding, the parameters are definitely current, voltage, the speed at which you weld, that is rotational speed, right? And what angle you are keeping that electrode. We have got something called a flux material. So mechanical engineering, they'll be knowing it. A flux material, a filler material, all those things are there. They are all parameters. Based on the parameters, you do optimization. Optimization, everybody knows. What is optimization? Definitely manufacturing or management, people would have got some knowledge on optimization also, right? Okay. So we do optimization, we will fix all the parameters. Quite interesting. After the slides, there's a real question for all of us. Not only for me, for all of us, I have a question, right? So with these parameters, you do that quality weld. So for that, I need to measure the parameters, right? Whatever the parameters I'm fixing it up, that has to be monitored. To monitor those parameters, I'll have to measure it continuously. So if you could see this diagram, there is a person sitting on top of it. You could see, right? I'm welding. This is made up of carbon steel. The carbon steel melts at a temperature of around 1500 degrees centigrade. Imagine the temperature. at that particular point. In this particular point, imagine the temperature. He's sitting on top of it. In addition to that, if you want to have a perfect weld, these two components must be preheated. Before welding, they must be heated. That's what we call it as preheating. That should be preheated somewhere around 400 degrees centigrade. Already it is 300 to 400 degrees centigrade. The heat radiation will be there. The person is sitting and he is monitoring, and you have to measure the speed. It will be rolled. A filament will be coming here, a welding rod. Probably you might have seen, everybody might have seen that welding rod. What is welding? We have, along the roadside you have a number of welding shops. How they are welding, I think that basic understanding will be there. A filament will be coming like this. It will be heated, this is welded. Even the filament temperature is 1400 degrees centigrade. Coming down, he has to measure the speed of the filament that is coming down. He has to measure the volume of flux material that is applied, and he has to come down and measure the speed of the rollers. Because the filament will come down, these two pieces together will rotate. I have to measure the rotational speed. That is the speed of my welding. Right? Come down, measure the speed. Go down and see the quantity of the flux material. Check the temperature. Check the current. It has to come down now. See to the miserable life of this person. The miserable life. I'm saying it's a miserable life. Though he's working in L&D, right? He's getting paid, but the life is really miserable. So what do we do for that? What do we do for that? It's a big question now. It should not be left like that. That is not engineering. Engineering, the science and development, the technological development is for the benefit of human beings, right? End of the day. But we are forgetting it slowly. Right, anyway. Right. He has to do this. Now, with these process parameters, what I can do? What is the possibility? We have selected a lot of parameters. I am optimizing those parameters. What is the outcome of optimizing those parameters? What would be the outcome? Sir, anybody can answer. Please don't think that I'm a teacher and questioning you. We are discussing, sir. The floor is open for discussion. Right? What would be the outcome of any such optimization?
A good weld.
A good weld, a quality weld, no defects. That is the outcome, right? So, then, in what way these optimizations, of course, optimization you do using ANN, artificial neural network. That is everybody do agree with me. In what way this ANN will help or will reduce the adversities of this man, the pain of this man? In what way your ANN will help this guy to get rid of his difficulties?
Since all the parameters are known and we know what the output we expect, it can be automated.
It can be automated, right? It can be automated. In that way, we can bring about a kind of a solace to this human being. Fine? Is that enough? You can automate it, but you need a person over there. That must be monitored continuously, right? Of course, automation is one such example. Is it really only the automation brings solace to this person? Is another question, right? How we brought that automation, I'll show it to you. Right. We gave an AC cabin to this guy now, because he has to be protected from the heat, from the radiation. So for which we are giving him an AC cabin. Whatever you said is fine, automation. How that automation is achieved? How that automation can be achieved? Simple answers. Yeah. Don't think that I'm questioning. We are discussing, sir. Don't get to that mode. Hey, this guy is asking question. No, we are discussing. How that can be achieved, sir? It's a general aid. Can anybody's ma'am? Sensor. Data capturing is important. Using sensors, you capture the data. With that data, you do all your analysis. You do your optimization. That is needed. Of course, cloud computing is also there. This data capturing is important. So we use sensor technology. We use sensor to measure the speed. We use temperature sensors to measure the temperature. We use current sensor to measure the current voltage. We use the temperature sensor. What is the preheat level? Having captured all this data, we gave them a kind of a support by creating a data logger. With that data logger, this person can sit in the AC cabin and monitor whether the parameters are exactly what the requisite parameters are to have what you said is a perfect weld. He's monitoring it. So he's sitting there in the AC cabin. He's monitoring the entire process. See, this is the weld, that reactor. This is the electrode, what I told you, no? That is coming down, filament. And this is the filler material that covers the belt. And with the sensors, I am measuring the speed. The temperature sensor measures the temperature, current and voltage is measured, and they are all connected to the data logger. In the data logger, he sits and just monitors, right? If so much of sophistication is given, right, to a welder, I think this particular sentence of mine should be edited. I'm going to say now. Will the corporate, it has to be edited, my request. Even if it goes there, no problem.